All right, good afternoon everyone and welcome. This is the Fireside Chat with Tanmay Bakshi, powered by DigitalOcean. My name is Mohan Ram and I head partnerships at DigitalOcean. All right, so Tanmay is a software and cognitive developer. He's the author of Hello Swift and an avid YouTuber who shares his knowledge on his YouTube channel called Tanmay Teaches. He's on a mission to help 100,000 aspiring coders innovate through open source coding. He's been using cognitive computing, cloud computing, and IoT to augment human capabilities in the fields of healthcare, special needs, education, teaching, music, and business. His goal is to use the power of cognitive in fields like healthcare to unlock the huge power of the human brain. Tanmay, welcome, and thank you for joining us today.
Thank you very much. I'm glad to be here.
Great. So to get started, do you sort of recall the first moment you were fascinated by technology?
Definitely. I actually started coding and really started getting fascinated with technology at the age of 5 when I started out, just really experimenting with computers, I guess you could call it. At 5 years old, really anything would fascinate a 5-year-old. And computers at the time really fascinated me because I would watch my dad programming almost all day since he worked as a computer programmer. And so really at 5 years old, no matter what the computer would do, whether it be changing the color of the screen, adding 2 numbers, or even displaying my name on the screen, it was really, really fascinating, and I wanted to learn more about what went on behind the scenes. And of course, once I started exploring, and once my dad was able to give me the answers to my questions, I started working with programming, and every day my interest grew a little bit. And so eventually, though, I started working with more advanced programming languages like Visual Basic, C, and so, eventually started also using the internet and books as learning resources. However, at around 9 years old, I had my first iOS app, T-Tables, accepted into the Apple App Store. But after that, I released a few more iOS apps. But at around 10 years old, I started to lose my interest in technology. I started to sort of lose that sort of confidence in technology, I guess you could say, or my passion for technology. And the reason being that I found out they were so literal, so hard-coded, they didn't have any of that sort of intelligent capability that humans have. They're just pretty much dumb machines that will do whatever we tell them to do, literally. And so I realized that really whenever you coded something, the moment you code that in, it starts becoming obsolete. However, at 11 years old, my confidence in technology came back when I stumbled upon a documentary about Ibm Watson, a cognitive computing platform that I'm sure you've heard of, that actually was not only able to play, but also win Jeopardy in 2011 against the 2 best human competitors. And so it really, really fascinated me as to how a computer can answer natural language Jeopardy questions. And not even just natural language questions. They're posed in the Jeopardy format and Jeopardy style. That really caught my interest, and at 11 years old I started working with cognitive technologies provided by Watson, and at 12 years old I started creating my own custom implementations of these sorts of cognitive code as well. And now at 13 years old I'm working with all the sort of cognitive technology in all sorts of fields like entertainment, healthcare, business, utility, security, and so much more.
Okay, that's great.
Thank you.
So, a lot of exciting things that you're doing, Tanmay. If you could give us a sneak peek into what a day in the life of Tanmay Bakshi looks like, what would that be?
Sure, definitely. Now, in my sort of day-to-day life, I guess you could say, apart from, of course, coding, and apart from, of course, implementing these cognitive solutions, I also absolutely love to record YouTube videos for my YouTube subscribers. It's really, of course, fun sharing my knowledge through my YouTube channel called Tanmay Teaches, where I love to teach about topics like computing, programming, machine learning, math, science, artificial intelligence, and neural networks, especially. And so, of course, apart from that, I also absolutely love, apart from all that sort of serious, YouTube subscriber, of course, recording those videos, and of course, apart from that, actually coding, I also absolutely love in my sort of free time doing stuff like biking, my favorite outdoor sport, when the weather in Canada allows for it.
Okay.
And apart from that, table tennis is my favorite indoor sport, and of course, playing tag and other games like that.
Yeah, and do you also kind of mark out time especially to learn?
Yeah, definitely.
Okay.
In fact, what I like to say is really even when I'm sharing my knowledge or whenever I'm recording a YouTube video
Yeah.
or coding, I'm always really learning. Because, I mean, for example, when I'm recording a YouTube video about neural networks, I might learn, say, 10 more things that I never knew about those neural network technologies. And then really what I feel is that it then becomes sort of my job to actually help fill this huge gap that I like to say of knowledge that the world has for these sorts of technologies. Because if you think about it, when I'm learning about neural networks, they're not heavily documented, right? It's not like you can just go buy a book and you'll know everything A to Z about neural networks. And so I really believe that there's this huge knowledge gap for beginners to get into neural networks, and from there it becomes a snowball effect of learning. So I really want to help them kickstart that snowball effect, and that is of course by sharing my knowledge about what I learn with the rest of the world through media like my YouTube channel and through the books that I'm writing about, like for example, Hello Swift, iOS app programming for kids and other beginners, and of course much, much more.
All right. So if there are youngsters or beginners who want to learn coding, where should they get started?
Well, what I definitely say, I mean, there are quite a few tips that I'd like to say, but one of them is that I believe everyone has to follow their passion, follow their heart when they start coding. You shouldn't be coding if you don't want to. You need to code because you want to, not because you need to. And so what I really mean by that is if you're not passionate about coding, and you're coding just because, oh, hey, yeah, we need to code, okay, I'm going to be getting a job to code, that's not really what coding's about. Like, for example, when I started coding at 5, really the reason I got that sort of kickstart of passion was because I really never knew the concept of a job at 5 years old. And so what happened is I thought this was just another toy, another way to have fun. And so what would happen is I would just, think, oh, I'm just having fun as I'm doing this. This is not work for me. And so since I didn't have that intention, since I was legitimately passionate about this sort of technology, I was able to grow that sort of passion and actually continue to work in that field. But apart from that, I'd also say that you need to start small, start easy, and start playful. You need to start off with simple languages like Scratch. Maybe not even a language. Just Scratch is a block-based programming language that allows you to learn the bare-bone concepts of programming in general. After that, you can move on to a very simple scripting language like Python or Java or Ruby, after which you can start to get more advanced with lower-level languages like C or Swift. And of course, from there, you can just continue your programming journey once you've actually started working with these sorts of technologies.
Got it.
And of course, though, there is one more tip I would like to share here, though, is that I really do believe that there's this thing called practice-based or project-based programming that I like. And the reason being, what this means is that you're not just reading a book or you're reading a documentation to actually, learn how to program. What you're reading, of course, you're still reading the documentation, you're still reading these books. But what you need to do is actually implement programs, actually create projects. And whether it be simple languages, like, I don't know, a GCF LCM number generator, whether it be a prime number checker, whether it be really anything else, even a Fibonacci number generator. Just implement these simple programs to teach you these sorts of bare-bone concepts of the programming language itself so that you can continue and actually learn from that. And again, kickstart that snowball effect. In fact, the book I've been writing, Hello Swift, is actually centered around project-based programming with lots of over 20 or 30 apps that actually show you the bare-bone programming concepts of Swift and actually programming in general and actually how you can implement them in many different use cases.
Got it. Okay. So, Tanmay, at 13, you've done a whole lot of things, right? Speaking at conferences, doing keynotes around the world, writing, YouTubing, all of that. So, what do you consider your most significant accomplishment?
Well, if you're talking about my most significant accomplishment, well, what I'd say, first of all, is my first IBM Watson project. And really, first of all, even stumbling upon IBM Watson in the first place. I definitely say that it's really a coincidence how I was able to stumble upon IBM Watson. And really, what I believe sort of the accomplishment in that is actually going ahead and taking it further. Because the thing is, what happened is, of course, once I stumbled upon IBM Watson, I was absolutely fascinated by its technology. And I found out that IBM Watson was converted into a set of tools that developers can leverage in their applications to create cognitive code in a simple way without having to have all the hardware, even having the cloud. You're paying for what you use, for example, and which is the benefit of this sort of cloud-based, service-based cognitive code. But really what I believe is that my first IBM Watson project, Ask Tanmay, I still believe, is generally a great concept. And the reason I believe this is because imagine IBM Watson, when I was originally developing Ask Tanmay, which is an open source natural language question answering system. I had the intention in mind for Ask Tanmay to have some sort of challenge. Like, for example, when IBM Watson was released, they would have IBM Watson play Jeopardy. And so to show that, IBM Watson's cognitive code is capable of doing so much. And so really when I was designing Ask Tanmay, which can answer your person, organization, location, and now date questions, really what I was trying to do is have some sort of challenge like that. And in this case, my challenge for it was to play a game show like KBC with Amitabh Bachchan. And so, in fact, I have actually gone ahead and tested out Ask Tanmay on a few different KBC questions, and it is actually working quite nicely. So that's just one of the goals that I do have for Ask Tanmay, and that was, of course, my first IBM Watson project that I still am, of course, continuing to maintain in an open source way on GitHub.
That's great, yeah. You also have set yourself this audacious goal of kind of inspiring 100,000 aspiring coders around the world, right? So tell us a little more about that project. Do you have a sort of a timeline in mind? And also, I know that you're kind of tracking the progress that you're making. About 4,000 people is what you consider you've impacted.
Yes.
Couple of questions there, right? So what's the goal for the project? How do you measure the impact?
Yes.
How do you consider 4,000 people? And how can people and companies kind of help you achieve that goal?
Yeah, sure, definitely. Now, of course, it starts off with the actual goal, and the goal is really to help and reach out to at least 100,000 aspiring coders, kid coders, beginners, and help them along their journey of learning programming and actually learning to code. And of course, not just learning, but also on their journey once they've learned how to code. And really what I believe is that I've already gone around 4,200 people there. And the way I like to measure this is really whenever I'm able to reach out to an audience. Like, for example, with NASCOM, I had a workshop with around 100 students. And so I was able to, reach out to, show them how to code, show them why cognitive is so important, and really tell them why they should be prepared for this artificial intelligence future that they're headed towards, and why they should be, prepared with this sort of technology. And so I believe that I was able to help them get ready for their future, which is why I incorporated them in this sort of list. Apart from that, whenever I receive an email or a tweet or a YouTube comment or something of that sort from a subscriber, asking for help, and I'm able to reply to them and actually help them out, I consider that actually reaching out and trying to help. And of course with my book, and how many people have already started reading this book, that I also consider as how many people I've reached out to. And so generally I really do believe that, of course, but as you did mention, the timeline. While I don't necessarily have a timeline or a deadline to get this done, what I do believe is that this is a never-ending goal. When I reach 100,000, my goal will increase. I'm just going to want to help out 200,000, 300,000, and even more. Because of course, if you think about it, artificial intelligence, which we haven't completely gotten yet to, but we will in just a moment, is definitely really the future of coding. And coding has already impacted our lives in such a way where even right now, we're presenting via technology, this microphone, these cameras, everything. This is all powered by this sort of coding. And artificial intelligence is that sort of next level of coding and next level of programming. And so I believe that these kids need to be prepared for their future, in which coding is a necessity, which is why, of course, I have this goal and why I'm going to continue to expand it in the future.
Last part of that question was, how would you like people who would want to help you in this goal
to
contribute?
Now, I mean, if you think about it, even right now, you're helping me out by doing this, because DigitalOcean, I mean, thank you very much, DigitalOcean, for actually inviting me to have this.
You're welcome.
I mean, I absolutely love working with these DigitalOcean, cloud servers that you provide. They're absolutely great. But apart from that, really, I mean, even what you're doing right now, you're helping me spread my message, spread what I want to share with the community, which is why I absolutely love having these sorts of talks. Because I'm able to spread my message and what I believe the future is, and is most definitely the future, and what I believe people should be getting ready for, and how I want to be sharing my knowledge with the community. I'm able to expand sort of my reach to other people to help them along their journey. Apart from that, like for example, even if I have seminars for other companies like Citibank or HSBC or Rivigo like yesterday, then what's happening is as I'm doing that, I'm helping out these coders who have already learned computer science, and they've gone through university, college, and they've learned computers inside and out. But now they need to be introduced to cognitive. They need to be introduced to artificial intelligence, which is definitely the future of coding. And that's why, of course, I'm here to actually show them this sort of technology and how it can actually be implemented.
That's awesome. Yeah. So tell us a little bit about some of the projects that you're currently working on.
Yeah, sure, definitely. Now this is actually quite interesting because, as I mentioned, I'm really using the power of cognitive in a lot of different fields. And whether this be deep learning implementations or deep machine learning implementations through services like IBM Watson, or whether it be deep learning through my own custom implementations, say Python or TensorFlow code, I absolutely love to implement these techniques. And I've done it in a variety of different fields. And there are actually two that I'd like to share with you today. It actually starts off in the healthcare field. And this is the field where I believe artificial intelligence is making the most impact. Because, of course, healthcare is a field where specialists can be augmented in such a way to not only save, but also really augment human life to the point where we're quite literally giving communication ability to those who don't have it naturally. Let me talk about that a little bit. So I'm actually a part of a project that's very close to my heart called The Cognitive Story. And the basic point of the project is to augment human life using the power of cognitive. And so this is actually a collaboration project between Darwin Ecosystem and Not Rocket Science, who are IBM business partners, as well as IBM itself and me. And so essentially the point of the first chapter in the cognitive story is to assist those with disabilities, to help them live better, easier, and fuller lives. And so essentially, my part is to actually implement the deep learning and machine learning backends of this technology. And actually, our first project is to work on, or is to help a girl in Northern Ontario, or just north of Toronto in Canada. And so she, of course, is quadriplegic. She cannot talk, she cannot communicate, and so that means if, for example, she's thirsty or if she's uncomfortable, she cannot communicate that. She just has to assume that someone will help her out. Someone has to guess that she's uncomfortable or thirsty and try their best to help her out. And so, as you can tell, that's of course not a very good life. And basically, the cognitive story is trying to use the power of technology to try and bring that communication ability to her artificially, even though she cannot do that naturally. In fact, if we can, I'd like to play a quick video clip describing Boo's story and how, of course, the cognitive story is trying to use technology to actually try and augment her life.
Sure, let's play the video.
All right.
Wow, Tanmay, that's a heartwarming and a great story, and I cannot imagine the impact that it's going to have on hundreds of other people like Boo,
Thank you
right?
very much.
Thank you for being a part of that project.
Thank you very much. I'm really passionate about it as well, because really, I mean, first of all, going up to Boo's house and actually seeing the condition that she's in, and it really makes me believe that what we're trying to do for her, and not just for Boo, really for everybody with similar disabilities, to give their communication and connection ability back to the world is really just absolutely great. And what I also believe is really the reason we're doing this is, think about this, if Stephen Hawking wasn't given communication ability, we wouldn't know half the things about the universe that we do today. Okay. And so imagine what sort of cognitive power could be locked in so many people's brains, but it's just unable to come out. It's unable to communicate or connect to us, which is why the cognitive story is, I believe, such a great project. And really, apart from that, as you mentioned, as you saw in the video, the back-end technology is really trying to use these sorts of EEG brainwaves and incorporating my deep learning algorithms and really just combining them to actually try and make sense of that secret sort of hidden language of the human brain that humans can never understand, but computers, because of their intense math skill and intense performance, are able to understand actually quite well. And so, of course, I'm working on this, especially with algorithms like LSTM neural network technology, and I cannot wait, of course, to show you what I've been doing in these fields in just a few weeks from now.
Okay, that's great. So you get to be a part of some high-impact projects around the world. So do you recall when you started getting some sort of global attention? Like when did Tanmay stop being this little guy who's curious about a lot of things, coding away, come into the limelight? How did that happen?
Well, I mean, it actually started at around 9 years old.
Okay.
Because at 9, when I created my first iOS app, well, of course, T-tables, which helps you learn your multiplication tables, my first interview was actually with a newspaper in Toronto called the Toronto Star. Okay, and so I had this interview, and of course, this was the first newspaper article I ever had, and so it was great. And so after that, of course, I did quite a few different media interviews with channels like CTV, Canadian Television Network, CBC, and a lot more. And this actually continued until I was around 10 and a half. But as I mentioned, after that, I started working with, general technology, and I started to lose my interest in technology.
Yeah.
But then once I actually started working with Ibm Watson, and after my mentors, my now mentors, James Archieri and Timothy Duncan, whom I'll talk about in just a moment, actually invited me to IBM Interconnect 2016 for a keynote on the main stage, actually, with around 25,000 people in the audience. That was really my first sort of major keynote, which actually sort of kick-started my journey with cognitive. But as I mentioned, I'd like to talk a little bit about the backstory, how I actually started working with cognitive in the first place, or with IBM in the first place. And so what happened, or not working with, I guess collaborating with IBM. And so what happened is once I released a YouTube video, my first YouTube video about an IBM Watson service called Retrieve and Rank. This was, of course, it was another video on my YouTube channel, quite a few views, of course, but that never really got the attention of specifically anyone. But I actually found a bug in the sister service of Retrieve and Rank, document conversion. And this bug was that instead of actually turning split up answer units for a document, it would just return the entire document in one answer unit. I won't go into that just yet, though. And so I posted that bug to Stack Overflow, but it still never got any attention. And so what I did is I tweeted about the bug, and that got the attention of a lot of IBMers. So now after that, though, two of those IBMers really caught my attention, and those were James Archieri and Timothy Duncan. And so now, of course, James and Timothy, they're my sort of big brothers now. They're not even my mentors anymore. And so now I really do appreciate really all the stuff that they're guiding me with, and really every step of the way, and how they're helping me out. And so, of course, from there, they invited me to IBM Interconnect 2016, and after that, I've just been, working with AI technologies in Watson ever since.
Yeah, that's awesome. Yeah. I also read somewhere that you kind of open sourced your first app that you released on the App Store, right? So I wanted to get your thoughts on open source in general.
Definitely, I'd be glad to. Because if you think about it, open source is a great technology. And the reason I believe that is because think about this. We've already got the wheel. Why reinvent it? We've already discovered fire. Why rediscover it? If we've already got deep learning libraries like Keras, why should we make other people create their own neural network libraries to implement them? Why wouldn't we just open source Keras, allow thousands of contributors to work on it over many years, and create such an amazing piece of software that anybody can integrate on almost any platform at this point, ARM, Intel, AMD, whatever it might be. You can integrate it on CPU, GPU, TensorFlow, Tiano, and more backends. And so it's generally really great what open source technology is doing, which is why I'm so passionate about this sort of technology. In fact, I'm actually keynote at the Open Source Summit in Los Angeles in just a few months from now in September. And so I'm going to be talking about why I believe open source technology is so great, especially with operating systems like Linux, which, I mean, imagine this, Linux is the world's fastest evolving operating system. It has the most security patches, the most kernel updates, and that's the reason being because it's open source, and we're able to create so much software on Linux and so much software for Linux, and actually have it expand and grow so much to the point that almost every server that you see, even DigitalOcean, provides these servers. I mean, at this point, you can just see that Linux is such a powerful technology because it is open source. It is almost impossible to create such a huge project without thousands and thousands of contributors from around the world contributing every single day, which is why I made Ask Tanmay open source, because I want to take this source code that I've got, make it available to everyone to contribute to collaborate with, to make it better, to improve it, whatever it might be, and to apply it to their own use cases. In fact, one more announcement, I know a few people here might be developers, and so this is going to be very exciting. The cognitive story is actually completely open source as well. Completely. A to Z, all into the spectrum. The cognitive code is completely open source, the LSTMs, whatever else it might be. The 3D printed headset schematics, as you saw in the video, the headset that we actually use to gather EEG brainwaves, completely open source. Even the sensors are open source. The software that controls it is open source. Even the data that we gather from the headset, from Boo, is open source.
That's great.
And so we really do welcome people to collaborate and contribute to the project, whether it be donating more code, whether it be improving the schematics for the headset to have Boo have a more comfortable everyday life, or even whether it be helping us with our cognitive code.
Yeah.
And we don't even welcome you to collaborate either. We also welcome you to learn from this code and learn from the source code that we're making available to you, to the public.
Yeah.
And of course to apply it to whoever else you may see fit, which is why we're making it open source.
Okay.
So that you can apply it to those who you think would love this sort of technology and would be benefited by this technology. In fact, soon I'm also going to be open sourcing another project of mine called Make Your Own Mozart.
Okay.
In fact, I'd like to get into a little bit of that now. Make Your Own Mozart is actually an application that I've created that tries to implement artificial intelligence in a very powerful field like entertainment. Okay, and so essentially this is actually quite a fun project. And instead of me telling you about it, first let's actually take a listen to it instead.
Sounds good. All right.
Thank you. So that audio clip over there was actually an audio clip. That's I mean, if you've heard a Mozart or Beethoven song before, of course, if you've heard one of their piano sonatas before, specifically, great. So that might have sounded a little bit familiar to you, right? A little bit of a tune of a Mozart or a Beethoven piano sonata, but that actually was not composed by Mozart or Beethoven. That project or that piece of music was completely composed entirely by a neural network. Wow. Okay. And so I've actually created an LSTM neural network that can actually take in 69 of Mozart's piano sonatas and 114 of Beethoven's piano sonatas and learn the A's and Z's of music. It'll learn how to generate valid music notation, what types of notes come after other types of notes, the chorus, the melody, everything. It'll even learn the genres of music. And once it learns, it'll then go ahead and generate new, original, good-sounding pieces that actually work and actually sound very nice. Now, there are actually quite a few different practical use cases for this. For example, I'm a YouTube content creator, and I want to put some sort of music in my videos.
Intro music.
Exactly, intro music, outro music. But the thing is, I cannot use copyrighted music. But I don't want to use royalty-free music either because it's been way overused by other YouTubers, and it sounds just silly at this point. And so what I need to do is take that royalty-free music and put it into an LSTM, like my Make Your Own Mozart project, or Google Brain has another similar project called Magenta. And so we'll just feed it into one of these systems, and it'll output new, complete music that I have the right to, that I can then use in my content that sounds very, very nice, but isn't anything that anybody has ever heard before. It's generally very interesting how these LSTMs work and how they're able to generate such good sounding music off of such little training data. And so really though, I also do have a few other things to say here. Like for example, then I know some people do think that, well, this is going to replace humans. We've got LSTMs that are generating art now. They're learning to be creative. How is this not intelligent? Super intelligent. And well, what I like to say to that is, remember, it's the humans that are training the computer, not the other way around. And so what's happening is we're training this LSTM to try and simulate great artists like Beethoven or Mozart. It's not the other way around. And this LSTM, it can't generate anything apart from Mozart or Beethoven.
It's learned.
It won't generate its own genre of music. We could develop an algorithm to do that, but it would be very, very difficult. Humans have that sort of extreme creative and imaginative ability to the point that they can generate new genres of music that sound amazing, something that anyone has never heard before. That sound absolutely great, which is what Mozart and Beethoven did, and that's what this LSTM cannot do, which is why it is such a powerful technology, and why it's not going to be replacing humans, but it's still powerful. And of course, apart from that, this project will of course be open sourced very soon on my GitHub as well.
Okay, that's awesome.
Thank you.
I mean, it's commendable that you're kind of really open sourcing a lot of these while also teaching people how to do it, but also knowing what to do, right? Once they've learned the skills. That's great. Let's talk about Tanmay Teaches, right? So how many videos do you have out already?
Currently I have around 137 videos on my YouTube channel.
Okay, and what's been the best part about this project, this YouTube project that you're...
Sure. I actually started on Christmas Day of 2011 on my YouTube channel. And originally it wasn't really anything much. It was just, okay, you know what, 2011, I'm around 7-ish years old, 7 or 8, and I don't really have much to do. Just before I eat or something, I'll say, okay, I'll just record a YouTube video about Visual Basic, for example. I'll just create a video about how you can create an application that can copy a file from one place to another, or display a message box on screen.
Yeah.
And once I got a Mac, then also terminal tricks and how you can do things like set your desktop wallpaper as a screensaver or something of that sort, or show hidden files in Finder,
Yeah.
or simple things like that. It started off as really just this sort of play channel where I'd create YouTube videos like
Yeah.
that. But eventually, I started getting into a bit more serious development with my YouTube channel, like for example, SQL videos. And soon I also had this goal of reaching out to 100,000 aspiring coders, and I started writing my book, at which point I started taking this a lot more seriously, and I started going with, things like algorithms. I would start to explain things like the A-star pathfinding algorithm. Breadth first search is actually something I just released. I also talk about things like the Dijkstra's shunting yard algorithm, Dijkstra's pathfinding algorithm, and of course many more algorithms like that. I also show you how you can implement those algorithms in Swift and iOS development. I also do things like Mac development. But then eventually when I stumbled upon IBM Watson, then a lot of IBM Watson videos, and now a lot of custom deep learning videos is what I'm currently working on. And throughout, of course, I keep creating things like math and science videos. I have videos about heredity and how genes work and how they're crossed from parents to children, and how, for example, if one of your parents has brown eyes and one has blue eyes, why do you have brown eyes?
Okay.
Why is that dominant gene? And so I talk about all that sort of stuff. And of course, math. One I just released is actually how you can use a predefined algorithm that I actually created myself to actually just transform shapes and points across a grid. And so of course I just love creating videos about these sorts of things. And really what I love about it though is actually seeing how right as I release a YouTube video, almost within 24 hours, I've already got 10 questions about the content in this YouTube video. And what I love is actually getting back to these people who ask me these questions to actually try and help them out while they're learning about these sorts of technologies.
Okay, that's great. You also mentioned about the book that you're writing.
Yes.
Is the book out or it's about to be?
Hello Swift, I've completely written this book. It's just going through the final proofreading stages with the publisher. And once that is done, currently though it's available for pre-order and you can actually get it now. You'll get an online version as I'm writing it. You'll see the updates of what I'm writing. It's called Meep by Mehening. And apart from that, if you pre-order it now though, you can also get the hard copy shipped to you when it is out.
Got it. So what's your process to writing? Do you sit down to write every day, or do you kind of put out blogs or articles and then kind of collate them into the book? What's your process?
Well, what I actually love to do is, first of all, I have this entire sort of plan of what's in the book. And so it really depends on what the step is, because the thing is, there are lots of different steps to writing the book. Now that I've written all the chapters, before it would be something like, okay, I would write a chapter from beginning to end, then I'd go through it a few times, really make a lot of corrections, add much more content into it, and then I'd send it over to the publisher where they do, their steps, and in between they'd send it back to me and I'd work on it, then I'd send it back to them. It would be this, back and forth process of just editing and reviewing until finally it gets to the Meep stage, at which point it becomes available to the users who have pre-ordered. And then from there, they have that, and I keep working on older chapters, keep writing new chapters. But now that that's all done, I just keep working on older chapters, making them better, and once the book is final and once Swift 4 is released, then this book will be released as well.
Got it. Awesome. You also told about your first app, right? Were there particular challenges in getting it released on the App Store?
Yes. Okay. My first app, T-Tables, was actually rejected around 3 times from the Apple App Store.
Wow.
First of all, the first time actually, the app wasn't taking the entire screen size of the iPhone. I didn't read the human interface guidelines properly enough. And so, apart from that, the second time, the button font size wasn't completely good enough, big enough. Apart from that, next time, the UI, it had something to do with the user interface and how it wasn't the user experience wasn't nice enough for iOS standards. And so, once I fixed all of those problems on both the iPhone and iPad versions, then I finally submitted it to the Apple App Store, and my first app was on the App Store. But apart from that, I do also face a lot of challenges in my everyday development as well, because now that I'm working with more complex technology like deep learning, it becomes a lot more complicated. For example, Linux is open source. That's great. It has a lot of patches every day, a lot of kernel updates, etc., and of course it's evolving very, very fast. But what I will say is that proprietary drivers with Linux do not work well.
Okay.
Because we've got open source drivers, and disabling the open source drivers and installing proprietary drivers becomes a big hassle. And so you must know about an operating system called Linux Mint, which is basically a layer on top of Ubuntu 14.04, which provides a lot more user-friendly features like pre-installed drivers and an entire driver manager. And when I originally got my deep learning computer with an NVIDIA GPU, it had Windows, but Windows isn't good enough for deep learning, so I swapped it out with Linux.
Okay.
And so Ubuntu specifically. But then CUDA doesn't work because it doesn't use Navu, the open source driver. It uses the proprietary NVIDIA WebDriver because, of course, NVIDIA wants you to use their proprietary driver. And so it took me a week. I called practically every single shop within a few kilometers radius of me and asked them, can you help me fix this, install Ubuntu with an NVIDIA driver? And it becomes hard because, of course, when you disable Navu, you can't access the XLF server, which is required to install the NVIDIA WebDriver. Yeah. And so from there, though, after a lot of hassle, I found out how to install the Linux Mint driver manager on Ubuntu to install the NVIDIA WebDriver for me, which finally got my system working, and finally I could work with deep learning and Python and Keras and that sort of stuff to create YouTube videos about these sorts of things.
Kudos to that persistence. All right. So when did you turn 13?
Excuse me?
When did you turn 13?
Oh, I actually turned 13 in October 16th.
In October. Okay. So has life changed in any way as a teenager?
Not really, no. Not necessarily changed.
Okay.
It's just, another year.
Yeah.
And now my birthday will be coming up soon as well again.
I know.
I'm turning 14 soon.
Yeah, absolutely. Tell us a little bit about your homeschooling experience. In India, it's not that
popular.
Yeah, popular yet. There are just a couple of cases, but you went to school for some time and then kind of chose to do,
until the middle of grade 6, I was actually regularly schooled. But after that, I was homeschooled. And really the reason was because if you think about it, my needs are different from what regular sort of school would provide. Because the thing is, I really like to tie in technology with whatever I'm learning about.
Yeah.
For example, if I'm learning about the GCF, LCM, Fibonacci numbers, or whatever else it might be, what I do is I'd be learning programming while doing my math homework. Okay, and so that really didn't tie in very well with regular schooling.
Got it.
And so I would do that with, of course, homeschooling. And so with homeschooling, it provides me that flexibility, first of all, with my schedule to actually do talks like this. And so apart from that, it also allows me to incorporate technology a lot more with what I'm currently doing.
Yeah. And do you have, is it your parents who kind of tutor you?
And my sister.
Okay, got it. Also, just kind of asking some basic questions here. Like on many occasions, people have referred to you as a prodigy, right? I want to kind of get your take on that. Do you think people are born with certain skills, or does everyone learn, and is every skill acquirable, like learnable?
What I'd say is that almost every skill is acquirable, it's learnable, but you have to have that passion sort of from birth, I guess you could say. You have to have that sort of passion, that sort of desire to achieve whatever you're trying to achieve before you can actually achieve it. And of course, that passion has to be nurtured and actually found in the first place, which is what happened at 5 years old, when my dad was able to find and actually nurture that passion that I had for coding, which is why that interest grew, and now it's with cognitive and AI and the next level of coding in general. And so, of course, I do believe that definitely skills are learnable, they're acquirable. However, I will say that you have to have the passion, you have to find that passion, and you have to nurture that passion along your journey of actually learning about whatever you're trying to learn.
Yeah. And what is generally your approach to learning a new skill? Like, for example, your various projects, be it YouTube, you need to learn how to make videos. To write, you need to learn how to kind of like put together a readable book, right? So all of these are new skills. What is generally, if it's a new skill, what is your general approach to learning?
Well, first of all, basics. Getting the basics down. And so starting off with, for example, I would say with coding or with cognitive code, you start off with something very simple. Training a neural network on paper, which is in fact what I was talking about yesterday at Rivigo, because they were all experts in computers, but they never worked with cognitive code before. And so I started with teaching them how to create neural networks on paper and train it with the actual math and logic behind forward and backward propagation. And so once you've got that sort of very basics down, then it really becomes experience. It's like you're working with this sort of cognitive code. Every day you're getting better at it, because, for example, just up until, say, 3 months ago, I didn't know how to implement implement convolutional neural networks in Keras, but now I know practically the ins and outs and how exactly to do practically anything with a convolutional neural network in Keras. And the reason being because every day I would experiment further, create an MNIST, CNN, cat-dog classifier, a logo classifier, logo generator with LSTMs and CNNs and actually GANs, which I won't get into right now, but it's going to be on my YouTube channel soon.
All right.
And so from there, what happened is I would just continue to implement these sorts of neural network technologies, and over time, that experience allows you to work with those technologies. In fact, what I would also like to say here is that while I was writing the book, every time I would write a new chapter, whenever I would get feedback from the publisher, whenever I would send it back to them, and, all this sort of communication that's going on, I gather experience over that. And once I'm done, say 13 chapters, the 14th chapter, the last chapter, is the best chapter I've written because I have that experience of all the chapters. I know what works, I know what doesn't work. Same thing with speaking. I started off okay at speaking, and slowly it got better and better because every time I would learn what types of audiences like this, what types of audiences don't, how should I speak to this audience and how should I not speak to the other audience. And so really generally that experience that you gain over time really allows you to learn how to do this sort of really whatever you want to learn or acquire and that you have the passion for over time.
Yeah. Very much like AI, but I think we're much more superior. We constantly take feedback and
And although technically artificial intelligence can with algorithms like deep reinforcement learning, it's still in its primitive stages. So it's getting there though.
All right. Yeah. Okay. So I have a couple of rapid fire questions.
Definitely.
Is that okay? All right. What's one thing that comes to mind when I say the following? Okay. India.
Heat.
Heat. Okay. Programming.
Open source code.
Okay. Homework.
Technology and how I can incorporate technology with my homework.
Okay. Friendship.
My YouTube subscribers and how I'm able to create friends through YouTube by actually helping them out. Like for example, what happened, this is actually a pretty interesting story that I'd like to quickly share.
Sure.
Back when I actually first started my YouTube channel and I created a YouTube video about Alamofire and how you can implement the Alamofire HTTP networking library in Swift for iOS. There was actually one of my subscribers that reached out to me. And so he said, okay, I want to use Alamofire for an application that I've got, and I've got a job interview. And if I don't finish this by tomorrow morning, then I won't be able to get this job, or this internship. And so what happened is it was around 12 a.m. at the time, midnight, where I was. And so I stayed up the entire night, around until 6 a.m. because his grandfather wasn't feeling well either, so he was busy. So I had to stay up until, I love this because it was really fun actually working on this, but I stayed up until 6-ish a.m. Actually working on this project and sending it back to him, and he actually got the internship after that. So I generally absolutely love doing that.
Yeah, that's fantastic. Thanks for sharing that story. Okay, just getting back to other rapid fire. Robots.
IoT.
Okay. Developer.
Programming, coding.
Okay.
And really cognitive technologies.
Okay. Tanmay.
Using the power of cognitive and artificial intelligence in fields like healthcare.
Okay, got it. Also, I know that you're an avid reader. What are you reading right now?
Well, currently I'm reading, generally, I do like to read, but specifically things like programming books. Right now I'm actually currently reading a book that actually my mentor, James, actually got for me at Ibm Interconnect 2016 about machine learning. And so it was written by James, not by my mentor, James, another James.
Sure.
Essentially, it's about unsupervised learning and supervised learning and how you can actually use it in programming languages like Java, which I'm actually currently reading. Apart from that, I'm also reading other books, I'm actually currently trying to learn the insides and out entirely of C and C++. In fact, I learned almost the entirety, not the entirety, really almost all the basics and concepts of Java within an entire day, which is why I was able to present Ask Tanmay at IBM Developer Connect last year.
Okay.
I had 1 week to develop Ask Tanmay, the second version of it, in June of 2016. And so I had that inside of that 1 week, 1 day was spent learning Java, and the rest were actually spent implementing Ask Tanmay.
Wow.
And so That's why I was able to present as Tanmay there.
Okay.
But I'm actually currently learning the insides and outs of C and C++ to actually implement GPU programs with CUDA and OpenCL. So I'm currently in the process of doing that, and I've actually got an entire CUDA series planned out. First part is already on my YouTube channel, and more will be coming up soon. And after that, I've also got an entire series, also by the way, planned on how you can actually implement deep learning technologies, not the training part, but the inference part, and how the inference part uses the CPUs on DigitalOcean. So I'm currently working on a series on that.
Looking forward to that.
Thank you.
Yeah. Also, is there a film that blew your mind?
A movie.
Movie.
Well, what I'd say, not necessarily blew my mind, but I absolutely love comedy movies. So definitely, I'd say the SpongeBob #1 and #2 movies. SpongeBob SquarePants.
All right. Okay. If Tanmay was a superhero, what superpower would he like to have?
Well, as I mentioned before, definitely being able to use the power of cognitive and coding in general, really in fields like healthcare to help those like Boo to really communicate and connect to the outside world.
Yeah, that sounds great. Yeah.
Thank you.
What is Tanmay afraid of?
Well, I mean, I'm not necessarily afraid of anything. What I could say, though, is what I don't like doing is definitely, first of all, eating vegetables.
Eating vegetables, okay.
And also creating tests for my code.
Okay. All right. That was in fact my question. Next question. What didn't you want to do, right? Yeah, okay. You have a lot of titles, right? YouTuber, algorithmist, author. Which one of those appeals most to you?
Well, I guess you could say there are two separate categories of designations I have. The keynote speaker, TEDx speaker, and other designations like that, and the algorithmist, cognitive developer, and more. And what I'd say is from the first category, I definitely say the cognitive developer and algorithmist. And the reason being, because I'm able to use algorithms, like for example, cognitive, in fields like healthcare and entertainment and cybersecurity, in order to really, first of all, even with DigitalOcean, every major or small company, even startup, is the threat of cyber attacks. Even DigitalOcean, I'm sure. And so cybersecurity is somewhere where DigitalOcean has to rely heavily. And so artificial intelligence can definitely augment their ability to defend against these sort of cyber attacks. And so machine learning is another place where I'm using this. But apart from that, in my sort of other category, I'd definitely say a general speaker, whether that be workshops, keynotes, TED, whatever else it might be. I love speaking, even here, because I absolutely love to, as I mentioned before, share my knowledge and share my sorts of thoughts with the world and with all of you about what I'm currently doing with these sorts of technologies and what I'm going to be doing in the future.
Got it. Yeah. Does Tanmay watch cartoons anymore, or has he kind of outgrown that stage? Okay. All right. Okay. I read in quite a few articles and interviews that you want to get your book signed by Amitabh Bachchan. Okay. If today we had Amitabh Bachchan in the audience, what would you kind of tell him or appeal to for a signature?
Well, really what I'd say is really share sort of my experiences with what I'm actually doing with this book and what I'm actually trying to achieve with it and how I'm actually trying to bring the power of coding to the youth and to kids, and not only the power of coding but the power of the next level of coding, cognitive and artificial intelligence. In fact, I've actually got more books about IBM Watson coming soon, and you'll learn more about that soon. Apart from that though, I'd also like to talk to him a little bit about how Ask Tanmay could play something like KBC. As you know, luckily the next season of KBC has been announced.
So awesome.
That's already been started, or it's going to be started very soon, and so I really can't wait. Who knows, maybe that could actually be a possibility. I really do hope so.
We do wish that comes true.
Thank you.
Yeah. Is there a technology out there that you're excited to learn about that you don't know of yet, or?
Well, there are lots of technologies in the world, and so of course I don't know about all of them, and there are lots of them that I'm very, very interested in finding out about. More specifically, there's a specific deep learning implementation called a GAN, a Generative Adversarial Network, that I'm very, very interested in because of the way that it can generate art. And so that's something that I'm definitely looking forward to actually getting into. Apart from that, other variations of RNNs like GRUs are very interesting, and I'm really starting to get into that and how you can actually implement those sorts of technologies.
Got it. All right. Out of all the experiences that you've had, was there anyone that kind of stands out where you really had to pinch yourself?
Well, I definitely say, first of all, having those IBMers reach out to me that day when I released the tweet about that bug, because it's really like, it's sort of unbelievable. Like, out of nowhere, I just posted this bug online, and now there are hundreds of IBMers just reaching out to me like, hey, how did you do this? They're sending me direct messages on Twitter. They're sending me tweets. They're doing they're sending me emails, and it's really just unbelievable. Where at that first moment, where it's like, okay, IBMers are reaching out to me. Why? Okay, what did I do? And so after that, though, once I actually sort of realized what was happening and realized how this is going, and then the second moment would be Interconnect 2016, when I actually got to present on the main stage with around 25,000 people, my first major keynote, and that was sort of like a big jump. It went from a few thousand, maybe like 1,000, maybe 2,000 people, to straight to like 25,000 people. So I absolutely loved that moment, and really the reason I loved it is because it was able to kickstart my journey of sharing my knowledge with everybody, and how it was really able to show people about my initiatives through like my YouTube channel and much more.
Got it. All right. All right, if we had a crystal ball right now, and if we could look into the future, what do you think Tanmay Bakshi would be doing when he's 25 years old?
Now, what I'd say definitely, this one I'm sure about, I'm not sure about anything else, but what I'm sure about is that I'm going to continue to use technologies like artificial intelligence to not replace humans, but to augment their abilities for the better. For example, what I like to say is that cognitive technologies and AI can be used as another tool in a cancer specialist's toolbox to diagnose and treat cancer, but it won't replace the specialist himself. And so definitely I'm going to continue to use these technologies in the field of healthcare to sort of augment the abilities of these doctors and allow them to work in lots of different fields at once in a very efficient and accurate way. That's definitely something I'm looking towards. Of course, advancing technologies like neural networks, and especially in fields like the cognitive story, where this is just our first chapter, our first project. Who knows what the cognitive story could be doing next, in, say, a year from now, when we're done working, or not done, we have finished this first project, and we're, of course, continuing to maintain it because it's open source. It's never going to end. It's just going to keep going until we stop maintaining it, which we won't. But apart from that, actually starting to use this power of cognitive in other fields like entertainment. Right now, I'm currently working on Make Your Own Mozart and lots of other projects coming there as well. Business is something that I'm very interested in. How you can actually augment businesses and their ability to create, for example, create products for their customers. And for example, what DigitalOcean is doing, how you can augment, for example, what DigitalOcean is doing with their cybersecurity, with whatever else it might be, with the power of cognitive. That's definitely something I'm looking forward to doing, and something that I am continuing to work towards.
Okay, all right. Can you share something about yourself that probably we've not heard of or read anywhere?
Well, what I'd say, first of all, well, I already said one of them, was the fact that I absolutely love comedy movies. Specifically SpongeBob SquarePants #1 and #2. But apart from that, I'd also like to, of course, as I mentioned, I absolutely really do appreciate and love all the guidance that my mentors really do provide me in really all sorts of fields. Like, for example, what James and Timothy are doing. And James is an IBMer and Timothy works for Darwin Ecosystem. And also, I wouldn't like to miss this opportunity and give them a quick shout out. Actually, because of course I absolutely love the guidance that, for example, my mentors Rob High, part of the Ibm Watson division, is giving me. John Cohn and Marcus Van Kempen from the IBM IoT divisions. Adam Holland from the Walmart cybersecurity division. Whether it be, and of course many more of my mentors that I really just absolutely appreciate what they're doing for me.
Okay, great. Finally, is there a question that I didn't ask but you'd like to answer?
Well, I mean, I think we did actually cover everything. I mean, apart from that, there are a few more entertainment, or sort of, I guess you could say, fun projects that I'm working on. Like, for example, there's actually a project called Nimble Ninja that I'm working on, that I have worked on. And Nimble Ninja is actually an open source iOS game developed by Michael Leach on GitHub. In fact, if we were to actually see here, I'd like to give you a quick demo of the Nimble Ninja system itself. And so I'm actually going to close this down here, so now we can actually switch over to the screen. Now, Nimble Ninja, we can actually start playing the game, so just move over to the other screen for me here. Alright, so you can actually start playing Nimble Ninja on the phone. Now, Nimble Ninja is this open source iOS game developed by Michael Leach. You can start to see the game mechanics over here. And so essentially the point of Nimble Ninja is for you to have a character, and he's running towards blocks, and so he has to avoid the blocks by flipping up and down on a platform. And so what's happening right now, as my dad is actually playing this game, he's increasing the score. Of course, he's currently 16, 17, 18, but once he gets to around 30, he would have got, okay, 19, it's good. Click game over, and then wait for a second. So we've lost the game. Click game over. Okay, so now just wait for 1 second. So we lost the game. But what was happening is as he was playing the game, Nimble Ninja started to gather data about what he was doing while playing the game. And now if you click tap to start and leave the phone on the table, what will happen is you can see, in theory, right, we got a block on the bottom. Nimble Ninja, oh, I think that wasn't enough data. If you actually double click the home button and slide Nimble Ninja up, double click the home button. Double click. And then slide Nimble Ninja up. No, go back. Slide it up. Okay, then click the home button once. And then slide over to the second page. And then click the Nimble Ninja beside Hoverpad. And above Snapchat. Do you see that one? It's on
The white one.
It's the white logo. Okay.
Yeah.
Click on it and start playing again, and this time get to a score of around 30. And theoretically, what should happen is we should be able to start the game again, and a neural network will learn from the data that we gather while playing the game, and it'll start to play the game for us.
Okay.
On our behalf, exactly like whoever just played play the game.
Yeah.
You can actually currently see right as we get to a good score, we will restart the game. We're currently at 20, 21, 22. And right as we reach 30, we will be good to go. This is currently being recorded. And there we go. We're at 30 now. And so the next block, you can just miss it. So you can now just lose the game. You can stop playing now. Okay, great.
All right.
And now, just give it a moment to load. It's training the neural network. Click the screen. And then click once more. And then now we can leave it on the table. And as you can see, the Nimble Ninja game should have theoretically played itself. I think what's happening is we're not actually gathering enough data to go through it. It would probably need around 40 to 50 to 60 iterations to actually gather enough data to actually play by itself. However, again, theoretically, that is how the Nimble Ninja game should work. What happens is as you play that game, as it gathers the data, it'll train that neural network to actually understand that data. And once it starts to understand that data, then it'll actually, of course, once the neural network has reached a sufficiently low error rate, it'll then go ahead and actually run by itself. It'll actually skip those blocks by itself. In fact, in my experience, I've seen that I can play up until around 50 to 60. And what happens is it goes ahead and plays till 5,000 or 6,000 for me. And just doesn't lose because it learns those patterns and it's able to play so much more efficiently than I ever could. And so, of course, this is using the power of artificial neural networks in these sorts of fields to actually, of course, play games. And so, again, really great example of how AI is being used in the entertainment field once more.
Very exciting. And
Thank you.
With that, I just want to open it up for the audience if we have any questions.
Definitely.
Yeah. Do you have anything in particular for students of class 6 and 7 in India?
Yeah, sure. What I generally say is that India is actually great with adapting to technology. Like, for example, what companies like IBM, Google are actually doing in India to implement AI solutions. And what DigitalOcean, for example, they're working on data centers in Bangalore, for example. They're working on those entire data centers there, and they just tweeted about that. So, I'm really excited about what India is doing with technology, but specifically for school students in grades 6 to 7. While there isn't anything specific I'd like to say here is there is one thing. I've seen that around the world, schools in the UK, Canada, the US are already starting to adapt, and I'm sure India now, to technology, and starting to introduce these kids through many different initiatives, like Everyone Can Code, Kids Can Code, Girls Can Code, and so many more to these sorts of coding technologies. However, what I will say is that we need to start bringing these kids to that next level of coding apart from block-based, text-based, and once we bring them to that, we need to start implementing these sort of cognitive technologies to make sure they're ready for the future. And of course, to these school students, not really the school students themselves, but really to the schools. That we need to be taking these initiatives to the next and next levels to really get them prepared for their future.
Yep. Yeah.
Thank you.
Any other questions? You have a question coming.
I'm just trying to formulate because there are quite a few thoughts about it. I see that there is a rapid pace of innovation that we are seeing, especially if you're talking about cognitive computing and we're talking about how we can augment human abilities. But what do you see as the roadmap the next like 5 years? Where do you see cognitive computing, or what kind of things do we imagine actually happening also and being available to general
yeah.
research? Because we hear a lot of things about IoT and all, but they are not really accessible at this point.
Yeah. So
we are like really hearing more general things, but not something
Specific use
kind of-
cases.
Yeah, like, and what is possible, what is actually already done, and what is it that we are aiming for.
So if you'd like to repeat the question for the users on the recording.
No, I think we've got
okay,
her on
perfect,
camera.
perfect.
Yeah.
So what happens, really what I believe here is that technologies like artificial intelligence and IoT are already a big part of our lives. Because think about this, when you want to check if you have meetings today, you don't go through your email and you scroll and you say, okay, what emails do I have that say that I have a meeting? No, you just ask Siri, what meetings do I have today? And it tells you all the meetings you have today, using machine learning and natural language processing to detect all the meetings.
Yeah.
And what happens is it's already such an integral part of our lives. That's just one example. I don't want to get started with noise cancellation and all that sort of stuff just yet. But what I'd like to say is that since AI is already such an integral part of our lives, it's going to grow in the future. And by grow, I mean it's really, I'd say random. And the reason I say random, it's exponential. But in between, there might be extreme areas of innovation. Because what happens is, like, for example, a few months ago, out of nowhere, this Google engineer, Ian Goodfellow, released a paper about GANs and how they can be used to create generative neural networks. And so out of nowhere, we went from knowing almost nothing about generative neural networks to almost everything.
Yeah.
Right? And so, maybe not almost everything, but knowing a lot more than we did before about these sorts of neural networks. And so what's happening is this AI growth is definitely exponential. Okay, but in between there are some really high growths of innovation. But if you're talking, like, for example, in the next 50 years, generally where will we be? I'd say that first of all, artificial intelligence will get into the hands of the everyday consumer. Because, for example, what Tesla's doing, they've got these really high-end cars that have autopilot. Imagine this, if we could bring a Tesla's cost down, and if we could improve autopilot, we've got a self-driving car ready for the consumer. And so that's really what artificial intelligence is currently doing. And technologies like IoT can also be implemented, for example, with Tesla cars to improve fuel efficiency, to improve the safety of cars, and so much more. That I really believe this is definitely going to get in the hands of many more consumers very, very soon. Maybe not even in the next 5 years, but 5 years is really where I believe we're going to see that sort of point where artificial intelligence is already such an integral part of our lives, but at the point that we actually start realizing it in our everyday lives.
Got it. We'll take one final question, if there is anything.
Yes.
Any particular reason why most of these AI algorithms are being open sourced? They're not voting in the companies, they're not voting back.
Well, what I'd say definitely here is that artificial intelligence is a very difficult field to work in. And so let's just say that convolutional neural networks, there was a person who invented these convolutional neural networks, and there's actually an algorithm that convolutional neural networks were based off of. It's a different type of neural network in 1960, 70, or 80, around that time frame. And that was actually the sort of primitive precursor to convolutional neural networks. They were very, very bare bone, but they worked almost exactly like a convolutional neural network, just only with convolutional layers. And so, of course, that was a very small algorithm, but it was open sourced. There were made papers about it. And at the time, there were only very simple computer vision algorithms. Like, for example, a human would have to manually fine-tune all these feature detectors and feature extractors, and actually eventually, after weeks of training, get this subpar neural network that can actually classify whether or not there's a bird in an image. Okay, and so it was very hard to create those neural networks. But imagine the benefit of open sourcing that primitive precursor to convolutional neural networks was that, first of all, that algorithm wasn't very good. Okay, however, people took that algorithm and they molded it in such a way that it's now almost the most popular neural network algorithm there is. And same thing for RNNs. RNNs were made public. There wasn't just some sort of API that creates RNNs or REST API and you can use it by yourself if you want to, and that you have to pay for. It was completely open source. The math behind it was open source. And that's why Google was able to introduce LSTMs, long short-term memory recurrent neural networks, that can understand when to keep long-term dependencies of information. And so what happens is the benefit of having these open source technologies is the rapid innovation that it allows you to really create with these sorts of algorithms. Because it's hard. You can't just have one person working on an AI algorithm and introduce an entirely new field of, for example, recurrent neural networks. You have to have thousands or hundreds of thousands of contributors to actually get to a stage where you have these sorts of algorithms that can really be used in our everyday lives in such a great way. Like, for example, what Apple's doing with their iPhones, or really what really Android or Apple are doing with their iPhones with dual cameras. The depth effect, powered by machine learning. What they're doing with, for example, the memories effect in iPhone. Machine learning. It detects, where you are, what types of photos have better memories, what types of photos aren't as memorable, etc., etc. It's all powered by these neural networks, which were only possible because they were made open source so many years ago.
Great.
One more question.
Sure.
Tell us more about data preparation.
Yes.
As far as machine learning is concerned, data is quite critical.
It
part.
is. Yeah.
So how do you prepare data? Where to start? How to go about it?
Yes.
For any beginners, actually.
Yeah, sure. Now, data preparation is actually the most crucial part for machine learning, because machine learning itself, if you think about it, humans have this great ability to filter out all noise. For example, I'm looking at you, and I'm not looking anywhere around me right now. Like, I'm focusing on you. I cannot perceive anything around me. And so what's happening is I'm focusing, and I'm filtering out all the extra noise, and I'm able to focus on what I'm talking about and what you're talking back to me about. However, what happens is computers aren't very good at that. When they look at something, they're not actually looking at it. They just know a bunch of pixels around the screen. That's all. And they don't even know that. They're just pixels on a screen. They're all individual components that just work together because they're electronically connected. That's all. And so what happens is data preparation allows you to filter out most of the noise that the neural network itself wouldn't filter out. And neural networks, don't get me wrong, are great at filtering out noise. Their entire purpose is to filter out noise because some data is not hard-coded. It's very variable. It can be, for example, with the iris plant data set that allows you to feed in things like petal length and how many petals there are, and it'll tell you what species of iris plant this is, iris flower this is. With that data set, there's no sort of exact measurement. It's not like if it's exactly 6.7 centimeters, it's this species. There's variation, there's genetic variation. And plus, that's not even a linearly separable data set. Right, you've got all this cross information, you've got the one class is linearly separable, but two of those classes aren't with each other, and so it's really complicated data that neural networks can filter the data out from. In fact, yesterday I was actually demoing an application that I've created which allows you to do neural networks, or use neural networks, for telemarketing call outcome prediction. So you can predict whether a customer will buy a bank account based off of their information, the bank's information, all the accounts they already have with banks, and you can predict if they'll buy a bank account from a telemarketing call. And so really how that works is I was able to prepare that data in the correct way. For example, machine learning is very sensitive. It only works with numbers, not words. And so you have to convert things like dates to actual numbers. And so, for example, if we're talking about a month, which last month was this user called? If it's January, you have to convert that one column of January to 12 columns with 1 and then 11 zeros. And so there's a lot of data preparation and normalization that has to go into neural networks, and you can actually get started with this, as you mentioned, for beginners, with simple tools like Python, R, and Neurof Studio are great ways to get started with this.
All right.
Thank you.
Great. Tanmay, it's been a pleasure speaking with you. Thank you so much for joining us.
Absolutely loved having
and
this talk
good luck
with
with
DigitalOcean.
everything. Thank you
very much.
Thank you.
Thank you. Thank you.